If you want to understand what infinity can do, we're going to need pizza.
Pizza. Yes, there's a science to making pizza.
We don't typically associate pizza with infinity.
Yeah.
So how can New York City's most famous food help solve one of the most elusive mysteries of early mathematics?
So, Steve, how is this pizza gonna help us understand infinity?
I would say it the other way. Infinity and the pizza are going to help us understand one of the oldest problems in math. What's the area of a circle?
Which is not intuitive.
No. You know, what's hard about it? You might think a circle is a beautiful, simple shape, but actually it's got this nasty property that it doesn't have any straight lines in it.
Right.
Ancient civilizations didn't know how to find the area of a shape like that.
How to find the exact area of a circle isn't obvious. For a square or rectangle, you just multiply the sides. But what do you do with a circle?
So what did they do?
Well, they came up with an argument that you can convert a round shape into a rectangle if you use infinity.
So we're basically gonna kind of deconstruct this pizza, make it into a rectangle.
Beautiful.
And then we're gonna know the area.
That's it. So I'm gonna start with 4 pieces.
Okay.
To do that, I'm gonna go 1 point up and 1 point down. And then 1 point up and 1 point down. And yeah, like that.
How'd you do in geometry?
You don't think that looks like a rectangle?
That is not close to a rectangle.
No, it's not. It's not. But come on, I'm only using 4 pieces. If I use more, I can get closer.
Okay.
So we got to cut these babies in half.
Let's cut them.
Let's rearrange them. Same trick, alternating point up and point down. So 1 up and 1 down, and 1 up and 1 down.
There. We are
That
ready.
is looking a lot better.
Oh.
What do you think? Is that a rectangle?
It's not quite a rectangle, but it's getting closer.
It is, right?
Yeah.
In both the 4-piece and 8-piece versions, half the crust sits at the top and half at the bottom. But with 8 pieces, the edge becomes less scalloped, closer to a straight line.
So we need to go at least a step further.
Let's go more. We got to do 16. So we have to just change every other one. Am I going to mess this up? I mean, that's a parallelogram that's aspiring to be a rectangle. That's got aspirations.
Yeah, it's got high hopes. It's got high hopes, I tell you.
From 4 slices to 8 slices to 16 slices and even 32 slices, there's a clear progression towards a rectangle. With 1 piece out of 32 cut in half to create vertical sides, the rectangle is almost complete, except for the wavy top and bottom. But as the number of slices increases, the straighter and straighter those edges would become.
And the argument here is that if we could keep doing this all the way out to infinity, so that this would be infinitely many slices, infinitesimally thin, this really would become a rectangle.
Yeah.
And we can read off the area.
That's
it's
right.
this radius, that's the distance from the center out to the crust, times half the circumference, which is half the crust, half the curvy stuff. And that's a famous formula, half the crust times the radius,
Yeah.
1/2 CR.
That's what the C is for.
Usually C for circumference, but you could see it's crust.
So at the limit, once we got all the way out there, it's gonna look like a rectangle.
It would be a rectangle, and that is actually the first calculus argument in history, like 250 BC, to find the area of a circle.
Who knew you could learn so much from pizza?